Hello, welcome back to my channel. Today we're going to talk about using special triangle on a unit circle fix. First, let's call the definition of what is a reference angle. A reference angle is the smallest positive acute angle formed between the terminal side and the x-axis. So three things. It has to be a positive acute angle, and also the angle should be located between the terminal side and the x-axis. Okay, here is some examples. I know last time in week 1 we just briefly talked about give out the definition what is a reference angle, but we didn't really discuss about diving to talk about what is actually reference angle, and I didn't show you examples. So here we are. So here we have an angle theta, that's the terminal side. This is theta. Theta is equal to 145 degrees. So look, the angle has to be formed between the terminal side and the x-axis. So where is it? Well, should be here, right? And look at here, this is still, we want it to be a positive angle, and we want it to be acute. Acute means less than 19 degrees. Okay, so this angle is definitely less than a 19 degree. So this is going to be theta prime. Whenever we have a reference angle, we will use the angle's name and then prime to represent the reference angle of that angle. If the angle is t, the reference angle will be t prime. If the angle is tau, and then the reference angle should be tau prime. All right, so how do we find what's the degree of this angle? Well, think about it. The whole angle here is 118 degrees, right? So that means our theta prime is equal to 118 minus 145 degrees, which is 13.5 degrees. So that's our reference angle for our theta. Now, so sometimes it's not necessary to be the supplementary angles of the original angles, but you need to follow the reference angles definition. It's always the terminal side with the x-axis. So here is a second example. Here is the coordinate plane, and I have an angle in here. So here is our angle t, which is equal to 5/4 pi. Again, I want to use more the radians notation. So which one would be our reference angle? Well, by definition, the reference angle should be the terminal side formed with the horizontal side. So we have 1 and 2. Which one do you think is t prime? Should be the second one, right? Because you not only has to be formed between the terminal side and the x-axis, also it has to be acute, which is less than 19 degrees, which the second one is less than 19 degrees, and we want this to be positive. So now how do we find this angle? Well, t prime. Oh, let's use a blue one. So t prime should equal to, look, in t, you can look at into this part. It was formed by two parts, the yellow part plus the blue part, right? So that means t prime is equal to 5/4 pi, and then subtract 118 degrees, which is pi. So our t prime is equal to 1/4 pi. So that's the reference angle of T. Last one, let me give you another example. I want you to pause this video and try to do it by yourself and find the reference angle, and then watch, see what is the answer. So here is our gamma. Gamma is equal to 315 degrees. What's the reference angle? All right, so this is going to be our gamma pi, and gamma pi is equal to, the total is 360, right? 360 degrees subtract 350, which is 10 degrees. So that's the reference angle. So what's the application of the reference angle? I am going to show you later, because we can use the reference angle to find out where is our cosine function, where is our sine function. Now, let's look at the special angles. Special angles. So special angles, you know that is 13, 14.5 degree and 60 degree angles. Now let's start with the 14.5 degree. In a unit circle, the reason why we use unit circle that much, because we know that the center, which is the vertex of the angle, is always on the origin, which is 0, 0. Another thing is important is because the radius is equal to 1 on a unit circle. So that makes the calculation very easy. Okay, in this triangle, I am telling you that this is 45 degree, which is pi over 4. What happens if this is 45 degree? If this is a 45 degree, that means this sine is equal to this sine. These two signs are equal. So in this case, we know that this is equal to 1. This is our y, this is our x. X is equal to y. So by using the Pythagorean theorem, we have x squared plus y squared equals 1. 1 squared, which is 1. And we know that our x is equal to y because this is a 45 degree triangle. So I have x squared plus x squared equals 1 squared, because these two, the value is equal. Now let's solve it. So I have x squared plus x squared, we get 2x squared equals to 1. So x squared is equal to 1/2. Then x is equal to square root of 1/2. Since this point is in the first quadrant, so it has to be positive. Okay, again, we talked about that in my previous video. I don't want you to leave it square root of 1/2. You have to simplify it. Simplify it means I don't want to see the radical in the denominator. So that means after we simplify, I have square root of 2 over 2. So this is our x, and the y is equal to x. So that means y is equal to also square root of 2 over 2. So that means we found our x and y is square root of 2 over 2, square root of 2 over 2. So now what happened is our sine pi 4, which is 45 degree, is equal to our y value, which is square root of 2 over 2. And our cosine pi over 2 also equals to square root of 2 over 2. And the tangent, if we know tangent, if we know sine and cosine, then we will know tangent, because tangent is equal to y over x or sine over cosine, pi over 4. So in this case, it's equal to 1 because they're equal. So that's how you get the answer of the special angle. Now, next, it will be our 13 degree angle. So in a 13-degree angle, let me draw the angle. Maybe this is not 13 degree. Okay, that's 13 degree. So on a 13-degree angle, which is pi 6, what happened to pi 6? And you know that the hypotenuse is the radius, which is equal to 1. And we know the hypotenuse is half of the opposite side of the 13-degree angle. So that means this is 1/2. So we don't know this. This is our x value, right? The horizontal value is the x value. Then we can use the Pythagorean theorem to find out x is equal to what? So we have x squared plus 1/2 squared equals to 1 squared. Simplify it. I have x squared plus 1/4 equals to 1. And x squared is equal to subtract 1/4 on both sides. I have 3/4 and take square root of it. So I have square root of 3/4, which is square root of 3 over 2. So that's our x value. So now we have our x, our y is equal to 1/2, right? So that means our cosine pi 6 is equal to square root of 3 over 2. Sine pi over 6 is the y value, which is 1/2. Cosine is the s value. And we have a tangent, pi over 6 is equal to our sine over the cosine, which is 1/2 over square root of 2. Simplify it, we have square root of 3 over 3. Okay, next one is the 60-degree angle. Again, since this is in a coordinate plane, not coordinate plane, unit circle, the hypotenuse, it will be 1. And this is pi over 3. If this is 1, and if you have in a right triangle one angle is 16 degrees, that means the other one is going to be 13 degrees. It's always 13, 60, and 90. So that means this sine is 1/2, and this sine we don't know. And this is y now, not x, because it's the horizontal distance. All right, so now, again, we use the Pythagorean theorem to find out the y value. And solve for y is equal to, actually, it's the same numbers here. So we can solve for y is equal to square root of 3 over 2. Or you can just do it by yourself. Now I'm skipping the step. You can pause it and do it by yourself. All right, now we found out the y value. So that means our sine pi 3 is equal to our y value, which is square root of 3 over 2. Cosine pi 3, which is cosine 60 degree, is equal to our x value, which is 1/2. And the tangent pi 3 is equal to sine over cosine. Oops, what's going on? Good. Which is square root of 3 over 2 over 1/2. Simplify it, it's square root of 3. So here are the special triangles that we have so far. Is 14 degree, sine, cosine, 60 degree, sine, cosine, tangent, also tangent, and 13 degree. I don't want you to just memorize it. When I was a student, we asked to memorize it. I don't want you to do it. I want you to be able to prove it by yourself, so that you don't need to just memorize everything, because I don't want you to think math is all about memorization. No, it's about the comprehension. So I want you to understand, where does the sine pi 3 come from? Where is the tangent pi 4 come from? Okay. Next, do some summarize. So if we have a unit circle, and in that unit circle we have 13 degree. Let me use different color. 13 degree angle. Our x is equal to the square root of 3 over half and 1/2 for the y. And then we have 45 degree. So here is the 45 degree. The x would be square root of 2 over 2. Y is also square root 2 over 2. That's the endpoint, the coordinate of the endpoint. And the last one is 60 degree. 60 degree. And the endpoint would be 1/2 square root of 3 over half. Okay, now let's do some exercise. What's the application for this? I want you to find the sine 135 degree and the cosine 135 degree. So we know that where is sine 135 degree? So that's where we need to use the reference angle. So 135 degree is in here, right? The black one. So which one, let's say this is theta. So where's the reference number? So the reference should be the terminal sine between the terminal sine and the horizontal sine, which is this one. This is our theta prime. So theta prime is equal to 118 degree minus 135 degree, which is equal to 45 degree. So that means our reference angle is 45 degree. So we found our reference angle, theta prime. And then we know that theta prime is 45 degree. So now let's take a look. Sine 45 degree is equal to, look at the blue one. I'm going to use the blue color because we have it labeled in blue. So in blue, we know that sine 45 degree is equal to the y coordinate of the blue color. That's the 45 degree, which is square root of 2. And the cosine 45 degree is the x coordinate, which is square root of 2 over 2. Okay, how does this relate to the 45 degree? In fact, the number are the same. The only thing is different is we need to be careful about the sign. So now the theta endpoint is in here, is in the second quadrant. So what's special about the second quadrant? The second quadrant is the x coordinate is negative, the y coordinate would be positive. So that means our cosine is going to be a negative. The sine is going to be a positive. So we know that sine 45 degree is equal to a square root of 2 over 2. Then when it comes to, this is the reference angle, right? When it comes to the actual angle, which is sine 135 degree, they should be the same as the reference angle. The number, the value should be the same except for the positive or negative. Since sine referring to the y coordinate, so this is positive. So that means these would be the same. But however, the cosine is going to be what? Negative, because the x coordinate in the second quadrant, it will be a negative number. So that means here should be equal to the negative of the reference number, which is negative square root of 2 over 2. So that's the answer. Okay, let's do another exercise. I know that this still looks very confusing. I'm going to draw a different graph outside of this. Now, I want to use pi now. So now I have an angle tau. This is a tau. So I want you to find, oh, let me use a negative. We haven't done negative right now. So let's use the negative. This is a tau, which is, if you're rotating clockwise, it's going to be a negative number. So tau is equal to negative pi over 6, which is, pi over 6 is what degree? Yes, 13 degree. So I want you to find sine tau, which is negative pi over 6, and the cosine tau, also tangent tau, which is negative pi over 6. They're all negative. So the first is we need to find where is the reference angle. Well, reference angle is the ending terminal side and between the x-axis. So tau primed is equal to pi 6. And also it has to be a q, which is less than pi half. Also it has to be positive. So now the reference angle is positive pi over 6. And now sine pi over 6 is equal to what? Now look back here. Sine pi over 6 is 13 degrees, which is the yellow one. Is sine is equal to 1/2. Cosine is the x-coordinate, which is square root of 3 over half. And we can do tangent later. Okay, so after we found the coordinate, now we need to look at where is the tau. Tau is in the fourth quadrant. So what's special about fourth quadrant? Fourth quadrant says that x is a positive, y is a negative. So that means x, which is our cosine, is a positive number, and our sine going to be negative. So in this case, our cosine negative pi over 6 is equal to cosine pi over 6, which is square root of 3 half. And then sine pi over negative pi over 6. Sine negative pi over 6 is equal to